There is a star in our galaxy that's going to explode soon, and it might just take the whole Milky Way with it. This star has already started to go supernova. We just haven't noticed yet. And when it does blow up, it will be so bright that if you were anywhere in the Milky Way, you would be able to see it during the day. But before that happens, we're gonna have a few warning signs, things that we can watch as the star expands into a red hypergiant and blows up our entire galaxy. So here's what's happening and how it's going to destroy everything. Betelgeuse is one of the most famous stars in the night sky. It is a red supergiant almost 700 light-years away. That means if you were standing on Earth, you could literally see this star with your bare eyes. In fact, it's the 10th brightest star visible from Earth. But the thing that makes Betelgeuse so special is that it's really big. It's over 700 times larger than our Sun. Now, the Sun is pretty small compared to some other stars out there. It's classified as a yellow dwarf, which basically means that it's relatively cool. Most stars are actually much hotter than our Sun, but they're also much smaller. For example, our closest neighbor, Proxima Centauri, is a red dwarf. It's less than half the size of the Sun and only 1/20th as bright. It is the coolest star in the Alpha Centauri system, but it still has nearly twice the mass of our Sun. There's also Sirius, the brightest star in the night sky. It's a white main sequence star that's 8.6 light-years away. It's about twice as massive as the Sun, but it's 25 times brighter. And then there's the blue stars. These are some of the hottest stars in the universe, but they're also some of the smallest. Spica is a blue star in the constellation of Virgo, about 260 light-years away. It's around 11 times the mass of the Sun, but it's 230,000 times brighter. That's why it appears so bright to us. But none of these stars come close to the sheer size of Betelgeuse. If our Sun was the size of a basketball, Betelgeuse would be over 15 kilometers across. It's so big that it doesn't even fit in the night sky. If you wanted to see the whole thing, you would need to have a telescope the size of Earth. But despite its massive size, Betelgeuse isn't actually very bright. It's about 300,000 times less bright than our Sun. But there's one part of the electromagnetic spectrum where it actually shines brighter than our Sun. Infrared. Betelgeuse is the brightest star in the entire infrared spectrum. Because it's such a huge star, it emits more energy at these longer wavelengths. It's not quite visible to the naked eye, but if you had infrared vision, you would be able to see it clearly. And that's why astronomers use infrared telescopes to study Betelgeuse. They can see through all the dust and gas that's obscuring the star and learn more about what's going on. But what exactly is happening? What's so special about this star? To understand what's happening, you need to know how stars work. Stars are giant balls of gas that generate energy by fusing hydrogen into helium in their cores. The energy from this fusion creates an outward pressure that balances the inward pull of gravity. When a star is born, it starts out as a giant cloud of gas and dust. As the cloud collapses, the material heats up and eventually reaches a critical temperature. At this point, nuclear fusion begins and the star ignites. Our Sun is about halfway through its life cycle right now. It will continue to fuse hydrogen for another 5 billion years or so, but it will eventually run out of fuel. At this point, the star will collapse under its own gravity and become a white dwarf. Some stars, however, are much bigger than our Sun. They have so much fuel that they can fuse elements heavier than helium. These are called massive stars. They can fuse up to iron, but after that they can't make any heavier elements. That's because the fusion of iron actually requires energy rather than releasing it. When a massive star runs out of iron, it can no longer support itself against gravity and it collapses. This collapse is so violent that it blasts the outer layers of the star into space. This is known as a supernova explosion. Supernova are some of the most energetic events in the universe. They can release as much energy as 100 billion suns. And when a supernova occurs, it can outshine an entire galaxy. That's what's going to happen to Betelgeuse. It's a red hypergiant, almost 20 times the size of our Sun. It's already started to go supernova. We just haven't noticed yet. You see, Betelgeuse has been in a binary system for most of its life. It orbits a smaller blue star. Together, they form the tightest binary system in the Orion constellation. About every 2 years, the two stars pass in front of each other, completely blocking our view of the system. During these eclipses, we can see Betelgeuse turn a deep red color. That's because the blue star is so bright that it washes out the red light coming from Betelgeuse. But when the blue star passes behind Betelgeuse, we can finally see the red light and it appears super bright. During these eclipses, we've noticed that Betelgeuse is pulsating. It's expanding and contracting every 400 days or so. The star is getting bigger and bigger, and it's shedding its outer layers, which forms a shell of gas and dust around the star. This shell is expanding at 6,000 kilometers per second. If something were to happen to this star, like say a supernova, the explosion would blast this shell into space. It could travel throughout the Milky Way, destroying everything in its path. And that's not the only thing that's happening. Astronomers have noticed that Betelgeuse has a very strong stellar wind. This is a constant stream of particles flowing outwards from the star. The stellar wind is created by the hot plasma that's rising from the core of the star. As it reaches the surface, it cools and forms a dense shell. This shell then gets blown away by the wind, and it creates a bubble around the star. This bubble is about 10 light years across, and it's expanding at 10 kilometers per second. The stellar wind is so strong that it's actually carving a hole in the gas and dust of the Milky Way. It's creating a huge cavity that could swallow up entire star clusters, and if Betelgeuse goes supernova, the explosion would blast this cavity to new dimensions. It could blow a hole the size of the entire Milky Way. The good news is that it won't happen for a few million years. Betelgeuse is still relatively stable. It's slowly expanding, and it will continue to do so for hundreds of thousands of years. But when it does explode, it will be so bright that we won't be able to look at it. And that's not the only thing that will be destroyed. Entire star clusters will be blown apart. The dust and gas will be thrown into space, and it will take billions of years to reform. It's hard to believe that this star will eventually explode, but it's already started to go supernova. We just haven't noticed yet. But when it does blow up, we better be ready. You see, stars exploding isn't anything new. It's been happening since the beginning of time. In fact, there are several supernova remnants scattered throughout the Milky Way. These are the remains of ancient supernova explosions. One of the best-known supernova remnants is the Crab Nebula. It's about 6,500 light-years away, and it's the result of a supernova that occurred in 1054. This event was witnessed by Chinese astronomers, and it was one of the brightest supernova ever recorded. The Crab Nebula is home to a pulsar, which is a rapidly rotating neutron star that emits beams of radiation. Pulsars are some of the most extreme objects in the universe. They can rotate up to 1,000 times per second, and they emit radiation in very precise pulses. So keep an eye on Betelgeuse, and if you see a bright flash of light in the night sky, run for cover, because it's coming.